possession, you should have like a red and a blue color, maybe orange and green would work fine. And you should have a jam jar lid and a straight edge. We're going to use these jam jar lids a lot. They're incredibly helpful. And so today we're talking about friendly angles and coterminal angles, which is vocabulary words you want to know for this today. All right, so you guys are fairly familiar with degrees. We learned on Friday that a radian is a length of a radius, and so if you have a circle centered on an axis, that it has a radius of length r, and what we can sweep out are angles using that radius as a unit of measurement, okay? And so we have this length r that we then sweep out that same length r, and what we create then is an angle. And this angle, that little notation right there, that little guy, he's called theta. He's a Greek letter theta. And that theta would be equal to, the measure of that angle is 1 radian. All right? Now, if I sweep out another radius length on my circle, another radius, well, now I have a new angle. And this new angle, how big is this new angle? 2 radians, okay? Because it's 2 radiuses swept out, all right? So that's what we learned about radians. Now, we also learned yesterday that degrees were so inaccurate, on Friday rather, the degrees were so inaccurate, they said we have to subdivide all of these degrees, not only into just degrees, but degrees, minutes, and seconds, so they can be a little more accurate, because it turns out degrees is totally random. Who said one rotation of a circle was 360 degrees? Why 360 degrees? Could it have been 1,000 degrees? Could it have been 2,000 degrees? Like, it could have been 6,000 degrees, right? Like, we could have taken a whole rotation and said, hey, we're going to make each right angle equal to 200 degrees. Like, it's completely arbitrary, okay? So instead, radians is a much better way to create angles. And so what we're going to do today is we're going to practice drawing angles in radian measure. And so I want you to go ahead. We are going to draw an angle theta equal to 3 pi over 8. Is this in degrees or radians? Radians. How do we know it's in radians? There's no degree symbol. Very good. So what I'd like you to do is I'd like you to take your jam jar lid, and we're going to trace it. So hold it tight and trace around it. And what we're going to do then is I would like you to take your straight edge, and we're just going to draw our horizontal axis. So as close to center as you can, I just want you to draw your x-axis. So this is our x-axis. And maybe I'm going to mark the center. We're going to pretend the center is right here. Okay. Now, to draw an angle in radian degrees, or in radians, this is saying take pi and divide it into 8 pieces. So on Friday, I said, hey, where's pi? 180 degrees. So what we're doing is I would start, if I were to draw my angle, I would draw my angle in standard position here along the positive x-axis. This would be 0 degrees. Over here is 180 degrees. And I said, hey, where's pi? Pi is at 180 degrees, and that is the same as pi. Those two things are equal. Well, this fraction is telling me, hey, take pi and split it into how many slices? 3. Not 3, 8. Take pi and divide it into 8 equal pieces. So first things first. Right now I have 2 dots here at 0 and 180 degrees, or 0 and pi radians. First I'm going to split it in half. Now how many pieces of pi do I have here? 2. All right. So, and then I'm going to split each of those in half. And you can imagine now, see, I have 1 wedge, 2 wedges, 3 wedges. I have 4 wedges. Can I get 8?
Yeah.
How do I get 8? Cut each of those in half. So this is pi, and pi is only the top half of our circle that we have to divide into 8 equal pieces. All right, so we have 8 little wedges of pi here. Now the rule is whatever you do to the top, we're going to repeat on the bottom. So we should have 8 wedges on top. We're going to have 8 slices of pie on the bottom as well. There I have 4, 5, 6, and 7, 8. All right, how many pieces to get all the way around the circle? 16, yeah, okay. So whatever you do to the top, you do to the bottom. Now, this for angle theta here, we want 3 of those pi over 8 slices. So here, yeah, here's 1 pi over 8. Here's 2 pi's over 8. And right here is 3 pi divided into 8 slices. So right here, my angle in standard position on the positive x-axis, and then it passes through 3 pi over 8. So this angle is 3 pi over 8. Pretty cool, right?
Yeah.
So we're going to do a couple more. Now, we have a couple more things to talk about here. So that's one angle. It says, so we just drew that angle in standard position. Now, we also need to determine the coterminal angles. Coterminal. All right. Coterminal is an angle that terminates in the same place. An angle with the same terminal side. Same terminal side. So you'll remember on Friday I said our angle begins here. This is the initial side of our angle. And over here is the terminal side of our angle. So what I need to do is we need to determine 2 coterminal angles that have the same terminal side. One is going to be a positive angle and one is going to be a negative angle. So what I have here is, I'm going to use, because I only had blue, I should have been writing in black this whole time. Purple. That'll work. Okay. So I'm going to find, first, I'm going to find a negative coterminal angle. What does a negative angle do? Sweeps downward, yeah? All right, so here's my negative coterminal angle. It starts here with the same initial side, but instead it's going to open downward, and it's going to go around in the negative direction, and it's going to terminate right here. It falls in the same spot. So the question is, what's the measure of that red angle that's sweeping out this way? 13 pi's over 8, let's count. This would be negative 1 pi over 8, and we keep counting. Negative 2 pi's over 8, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12. Yes, that would be negative 13 pi's over 8. No, so that is the negative coterminal angle. So one coterminal angle would be negative 13 pi over 8. Now the rule is you can't get the same angle, right? So we already have the angle of 3 pi over 8. So I need another angle. This one I want to go in the positive direction as well, but this one's just going to be bigger than a full rotation. Okay, so what if I start here at 0, and then I go all the way for one full rotation, and then land right here on my terminal side again. So how many pi's over 8 did we go this time? Yeah, all the way around it was 16 pi's over 8. Does that make sense to you, 16 pi's over 8? Yeah. Okay, 8 pi over 8, and another 8 pi over 8 would be 16 pi's over 8, and then we keep on counting. 17 pi's over 8, 18 pi's over 8, and then 19 pi's over 8. So our other coterminal angle would be 19 pi's over 8. So we have a coterminal angle that's negative, and we're going to have another coterminal angle that's positive. All right? You can't give the same answer twice. Okay. Now, 2 more things to talk about. Complement. Oh, it doesn't matter what color for this one. Okay. Do you remember from geometry? What does it mean if 2 angles are complementary? That's supplementary. So complementary is? No, 90. Complementary is adds to 90 degrees. And then supplementary are 2 angles that add to 180 degrees. Okay, so we have 2 more vocabulary words. All right, where's 90 degrees in my picture here? Yeah, 4 pi over 8. Very good. 4 pi over 8 is right here. And that would be like where 90 degrees would fall, right? So I want to know what's the measure of the angle when we add it to 3 pi over 8 that gets us to this angle straight up here. Yeah, it's another little wedge of pi there that we've got. So the complement is 1 pi over 8. Because 3 pi's over 8 plus 1 pi over 8 equals 4 pi's over 8. Okay. So where would supplementary adds to be 180 degrees? We know that 180 degrees is all the way over here. So this whole thing, what's the measure of this whole angle that gets us all the way? 5 pi's over 8. Very, very good. Yes. 1, 2, 3, 4, 5 pi over 8 wedges. So 5 pi over 8. So if you have your dots, count. Well, all we're doing is counting, right? Which is really kind of cool. Okay. It's really quite cool. I love it. I didn't learn it this way, but after teaching for 20 years, it starts to make sense. Okay, let's try another. So now my question goes back to, 360 degrees was 100% arbitrary. Could have been any number. Now, we have radians, so I can take pi and divide it into whatever I want, right? So, all right, let's see. If I go ahead and draw my little jam jar lid here, and I'm going to go ahead and cut it. Show my x-axis is going to be about right here, it looks like. So there's my x-axis. Oh, I should have been drawing in black again. Okay. All right, let me get black. All right. Give me a fraction.
14.
Give me an even number fraction because. So I don't want to. I could divide by 6. So let's draw an angle theta that is 5 pi over 6. All right. So there's the angle we're going to draw in standard position. Ladies and gentlemen, where is pi? Okay, so right over here is pi. It's equal to 180 degrees. And we also have 0 radians and 0 degrees. Okay? Now I want to draw 5 pi over 6, so I'm going to take pi and I'm going to cut it into how many wedges? 6. Right here it tells me. It says take pi and divide it into 6 equal pieces. So first I'm going to cut it in half. Now I have 2 wedges. What do I have to do with each of these? Do I just divide it into 2? That'd only give me 4. Oh, 2 dots on each side. Gotcha. So you'd technically be putting it into 3 places there. Yeah, and 3, and there you go. Okay, so now you can sort of see here's 1 wedge, 2 wedges, 3 wedges, 4 wedges, 5 wedges. How big is each little wedge here? 1 pi over 6. Very good. 1 pi over 6, 2 pi's over 6, 3 pi's over 6, 4 pi over 6, and here we have 5 pi's over 6. Again, the rule is whatever you do to the top, you got to do to the bottom, yeah? So we're going to split those up into 6 wedges as well. Okay. So how many wedges all the way around? 12. Okay. Good. 6 plus 6 is 12. So that's 12 pi's over 6 gets us all the way around. Great. Okay. So I'm going to draw my angle. My angle theta was in standard position. There's my initial side, and it opens out, sweeps out this angle right here, 5 pi over 6. So there is angle theta equal to 5 pi over 6. Okay, coterminal. Coterminal angle. I need a negative coterminal angle. So it starts with the same initial side. It always starts on the x-axis, positive x-axis. But it's negative, so we're going to go this way. And it's going to land and stop at the same terminal side. They sort of line up and run into one another. So what is that pink angle? 1, 2, 3, 4, 5, 6, 7. Good. Negative 7 pi's over 6. It's got 7 wedges in the negative direction. Right? Isn't this amazing? Who knew you were just doing counting in trigonometry? That's all it is. Okay. What do we have to do for the positive coterminal angle? A full rotation and a bit more, right? So here's our positive. So again, starts in the same place. And we're going to do a whole rotation, which is how many wedges? 12 wedges plus, yeah, so here, and then that's going to end at the same spot. So that would be 12 plus 5 is 17 pi's over 6. Isn't that great? I think it's fantastic. Okay, does our initial angle here, our 5 pi over 6, does it have a complement? Not exactly. It's already bigger than 90 degrees. So it doesn't have a complement, but it does have a supplement. What is its supplement? Yeah, so supplement gets to right here. So we need this extra bit right here, and that is a 1 pi over 6 wedge that we want to add to get the supplement. Okay. Do you think you get this? Yeah. Okay, will you draw a small circle? Just freehand a little small circle. Yeah, you don't need to make it gorgeous. But a little reference circle, again. Will you do, will you draw, how would you do, like, I don't know, 3 pi over 5? So here's 0 radians and pi radians. And what do we have to split pi into? 5.
So overall it'll be just 10%.
So 4 dots on top, and 4 on the bottom will give you 5 on top of that. Does that make it's so weird, right? So it's really hard to split it into odd numbers, but it takes a little bit of practice. Yeah, you've got to be a little bit savvy, but you're right. You use one less dot, and that'll give you 1, 2, 3, and then 4, 5. So get your 5 wedges on top and repeat on the bottom. How big is each wedge here? 1 pi over 5, yep, 1 pi over 5. And so 3 pi's over 5, what quadrant does that land in? Second quadrant, yeah, second quadrant. Let's see, 1 pi over 5, 2 pi over 5, 3 pi over 5. There it is. There is my theta equals 3 pi over 5. So what we love about radians is that it's not a pre-prescribed degree size, right? So degrees are exactly 1/360th of a circle. But here we can take pi and we can slice that sucker up into as many little baby wedges as we want, right? So we can make this infinitely more accurate all day and night. So we could draw, 13 pi's over 24. We could draw, if we really wanted to, we could draw 997 pi's over 1,000. We could take pi and we could cut it into 1,000 pieces. Of course, we're not going to do that, but good. And we can make it as accurate as we want. And so that's why radians are much better. So today you guys are practicing drawing angles, not only in degrees, but in radians as well. So the front is degrees and the back is radians. Read the directions question.
So when you're doing complements, you can't do it if it's not as big as...
If it's bigger than 90, it doesn't have a complement. If it's bigger than 180, right. So if it was bigger than 180, it wouldn't have a supplement. Yeah, of course, I'm not going to ask that. So, but yeah. All right, cool. So I would recommend starting with what we were just doing, which is the back side of this page, because degrees are easy. So try the radian side first.
Should we do the back side first?
I would do the back side because that's what we were just doing. So many absences today. It's crazy.
I feel like Thomas is here, but I guess not.
No, I thought I saw him. I thought maybe it was probably last night that it was just like
I totally meant to go, and then we were cooking. We were cooking dinner, and then I was running a little bit late, and we were eating, and I was like, and then I got up, and someone said something, and I was like, oh crap, it's supposed to be it. Oh, I wanted to go, I really did.
Whose head fell off? It was yours.
No, mine was the good one.
All right. Oh, I'm still recording.